These are your notes for Unit 4, Day 3 of Algebra 1. If you would like to see the warm-up, homework questions, or review question we did in class today, just look at the finished notes. So today we're going to learn how to solve absolute value equations and absolute value inequalities. So absolute value equations. Let's review what absolute value means again. So remember, when you have absolute value, you've got those straight up and down bars. And so you could have something like the absolute value of 3. And remember what absolute value is. It's saying how far away from 0 is it on the number line. So the absolute value of 3 is saying how far away from 0 is 3 on the number line? Well, it's 3 units away from 0. So the absolute value of 3 is 3. Or if you wanted to find the absolute value of -3, it's asking how far away from 0 is -3 on the number line. Well, -3 is also 3 units or 3 spots away from 0 on the number line. So absolute value is a number's distance from 0. Well, let's say that we know that the absolute value of something, an unknown number, is 3. So this is saying what numbers are a distance of 3 from 0. So if it wants to know if the absolute value of x is 3, it's saying what two numbers have a distance of 3 from 0. Well, that would be +3 and -3. So the absolute value, if the absolute value of x is 3, then x is equal to +3 or x is equal to -3. And you can write it as two separate answers, or what you'll see be done a lot is you can write x equals plus or -3. So x equals positive or -3. That's how you would read that out loud. So x equals plus or -3, positive or -3, or you could write it out as two separate answers. So on that first one, number 1, it's saying that the absolute value of x is equal to 5. So it's saying on a number line, what numbers are 5 away from 0? Well, if I move 5 out in both directions, then I would be at +5 and I'd be at -5. So the two solutions to the absolute value of x is equal to 5 is x equals +5 or x equals -5. Or you could write x equals plus or -5. Either of those will work. If the absolute value of m is equal to 8, then it's saying on a number line, what numbers are 8 away from 0? Well, the two numbers that are 8 away from 0 are -8 and +8. So my two answers are m equals plus or -8. If the absolute value of w is -1, it's saying what number is -1, a distance of -1? Well, absolute value is always positive, so this is going to have no solutions. So remember our ways to write no solutions. You can write 0 with a bar through it. You can do the empty set notation, the empty birdie brackets, or you can say no solution. Any of those ways would be okay. So again, absolute value of something cannot be negative. All right, the absolute value of y is 0, so what number or numbers are 0 away from 0? Well, only one number is 0, so the only solution to this would be y equals 0. All right. Well, what if it's not just x or y or w or p on the inside of the absolute values? What if you have an expression like the absolute value of 2x minus 5 is 11? So it's saying that to begin with, I'm at an absolute value of 11. So the two places that I could possibly be at are +11 and -11 to begin with. So what you're going to do with absolute value equations is you're going to set up two equations. So either 2x minus 5 is equal to -11 because the absolute value of it is 11. So it's either at -11 on a number line, or 2x minus 5 is equal to +11. So you're going to set up two equations. It can either equal the positive value of the number or the negative value of the number because its absolute value is 11. So it's 11 units away from 0. And then you would just solve each of these equations one by one. So to solve the first one, add 5, and we have 2x is equal to -6. And then divide by 2 and divide by 2. And one of my solutions is -3. Again, you can always check by plug it back in. If I took -3 and plugged it in, I would get 2 times -3, which is -6, and -6 minus 5 is -11, and the absolute value of -11 is 11, so -3 works. Let's try the other one. 2x minus 5 equals positive 11. Add 5, add 5. 2x equals 16. Divide by 2, and x is equal to 8. So if I took 8 and plugged it back in, 2 times 8 is 16. 16 minus 5 is 11, and the absolute value of 11 is 11. So either x is equal to negative 3 or x is equal to 8. And those would be my two solutions for that problem. On the next one, we have 3 is equal to the absolute value of 4 minus x divided by 2. So since my absolute value is equal to 3, I'm 3 units away from 0 to start with, so I'm either at negative 3 or positive 3 to start with. So my quantity inside the absolute value, 4 minus x equals 2, is either equal to negative 3 or 4 minus x over 2 is equal to positive 3. And then I would solve both of these. So subtract 4, and negative x divided by 2 equals negative 7. And then I'm going to multiply both sides by negative 2 to get rid of dividing by negative 2. And I get positive x equals positive 14. So one of my possible solutions is x equals 14. If we tested that out, plug 14 in. 14 divided by 2 is 7, and 4 minus 7 is negative 3. The absolute value of negative 3 is 3, so 14 works. And on the next one, I'm going to subtract 4 and subtract 4. And I get negative x over 2 equals negative 1. Then multiply both sides by negative 2. And I get positive x equals negative 1 times negative 2 is 2. And if I took 2 and tried to plug it back in, 2 divided by 2 is 1. 4 minus 1 is 3. And the absolute value of 3 is 3. So my two possible solutions are x equals 14 or x equals 2. All right, so that's if you already have an absolute value of a quantity is equal to a number. What if the absolute value has some other stuff surrounding it? So like number 1, 2 times the absolute value of x minus 3 is equal to 9. So your first step is you need to get the expression in absolute value alone on one side. So you want to get the absolute value expression alone on one side. So how do I get the absolute value expression alone on number 1? Well, first I'm going to get rid of the subtracting 3, so I'm going to add 3 to both sides. And I have 2 times the absolute value of x is equal to 12. And now to get the absolute value alone, I have to divide by the 2 in front because it's 2 times the absolute value of x. And now I have the absolute value of x is equal to 6. All right, well, if the absolute value of x is equal to 6, I'm either at positive 6 or negative 6 on my number line. So my answer is going to be x equals plus or minus 6. On the next one, negative 3 times the absolute value of 2x minus 1, then minus 4 is equal to negative 16. The absolute value is not by itself yet, so it's okay that it's negative 16 for right now. So to get the absolute value expression by itself, I'm going to add 4 to both sides. Then I have negative 3 times the absolute value of 2x minus 1 equals negative 14. Nope, negative 12. And then I'm going to divide both sides by negative 3. And then I have the absolute value of 2x minus 1 is equal to negative 12 divided by negative 3 is positive 4. And now we're okay. So now we have an absolute value expression is equal to 4. Well, if the absolute value is equal to 4, then I'm either at positive 4 or negative 4. So I'm going to set up two equations. 2x minus 1 is equal to negative 4, or 2x minus 1 is equal to positive 4. And then I'm going to solve these one at a time. So I'm going to add 1, 2x equals negative 3. Then divide by 2, and one of my possible answers is x is equal to negative 3 over 2. Same thing for the next one. Add 1, 2x is equal to 5. Then divide by 2. My other possible answer is x is equal to 5 over 2. So my two possible solutions are x equals negative 3 over 2 or x equals 5 over 2. What if we have absolute value is equal to another absolute value? Well, remember the idea is that you would do plus or minus. So I'm going to do 4x minus 1 is either equal to the positive version of 5x plus 3, or you would do 4x plus 1 is going to equal the negative version of 5x plus 3. So if you envision this to be some sort of number, like if you had the absolute value of 4x minus 1 equals 5, then you would say 4x minus 1 equals negative 5, or 4x minus 1 equals positive 5, right? Well, again, we're going to have the positive version and the negative version of what it would equal. So distributing a positive 1 doesn't change it. So we would have 4x minus 1 equals 5x plus 3. And then I would solve it. Got to get all of my x's on the same side. So subtract 4x and subtract 4x. And you get negative 1 equals x plus 3. Then subtract 3, and maybe negative 4 is a possible solution. Let's plug that back in and see if it makes sense. If I plug in negative 4 into both sides, I would get 4 times negative 4, so negative 16 minus 1, I would get negative 17, and the absolute value of negative 17 is 17. If I took negative 4 and plugged it in the other side, 5 times negative 4 is negative 20, and negative 20 plus 3 is negative 17, and the absolute value of negative 17 is 17, so the negative 4 works. If I try the other side, 4x minus 1 equals negative, and then the quantity 5x plus 3. Let's distribute. We would have 4x minus 1 equals negative 5x minus 3. Get all of my x's on the same side, so I'm going to add 5x and add 5x. And then I have 9x minus 1 is equal to negative 3. Then I'm going to add 1 to both sides, and I have 9x equals negative 2. Then divide both sides by 9. And x is going to equal negative 2/9. So those are my two possible solutions. Why don't you pause the video and try number 2 using the same method? All right, so 2 plus x is either equal to the positive version of negative x plus 7, or 2 plus x is going to equal the negative version of negative x plus 7. So on the first one, if I distribute a positive, it doesn't change anything. So 2 plus x is equal to negative x plus 7. Get all of my x's on the same side, so add x to both sides. And I have 2 plus 2x is equal to 7. Subtract 2, and 2x is equal to 5. Divide 2, and x would equal 5/2 as a possible solution. And then we have 2 plus x, distribute the negative sign, and you would get positive x minus 7. Subtract x. We have 2 is equal to 7. So on that side, you would have no solutions that would come from that. So the only possible solution is x is going to equal 5/2. All right, so those are absolute value equations. What about absolute value inequalities? What if I want the absolute value of some quantity to be less than some number a? So for instance, if I want the absolute value of x to be less than 3, then that's saying that I want the distance from 0 to be less than 3. So if you think about this on a number line, maybe it would be a little bit easier to see. So if this is 0 and 1, 2, 3, so that would be a distance of 3. This would be a distance of 3. But I want the distance to be less than 3. So what numbers would have a distance that are less than 3 away from 0? Well, all of these numbers right here and all of these numbers right here, so 0, 1, 2, and all the numbers in between those would have a number that's less than 3 on the number line. And then just like we did earlier, it's going to be an open circle and an open circle because it's less than 3. If it was less than or greater than, it's an open circle. Less than or equal to, greater than or equal to is a closed circle, if you remember. So on the next one, we have solve and graph on a number line. The absolute value of x is less than 4. So I'm less than 4 away from 0 on the number line. So I would first, 1, 2, 3, 4, that's exactly 4 away from 0, and 1, 2, 3, 4, that's negative 4 away from 0. I want the numbers that are less than a distance of 4. So the numbers that are less than 4 away from 0 are the numbers in between negative 4 and positive 4. What if you have an expression? So I want the quantity y plus 2 to be less than or equal to 3 away from 0. So to get started with, I could be to here, and I could be to negative 3. So I want my y plus 2 to be somewhere in between negative 3 and positive 3. So to do that, you're going to write that you want that expression, y plus 2, to be in between negative 3 and positive 3. Or you could also write it as 2 separate equations. So we can think of it right here. I want y plus 2, and since it's going to the left, I want it to be I want it to be greater than or equal to negative 3, because I want these numbers going this way. And then I want y plus 2, I'm going this way, to be less than or equal to positive 3. So you can rewrite it exactly like it looks, and that would be one expression. And then you rewrite it but flip the sign and make it negative if you're going to write it as two separate expressions. Or you can make the sandwich like we made them earlier. So if I were to solve this, I would subtract the 2, subtract the 2, and subtract the 2. And negative 5 is going to be less than y, which is going to be less than or equal to 1. So I want all of the numbers that are in between negative 5 and positive 1 on the number line. So close circle, and then all the numbers in between negative 5 and positive 1. So again, originally I want y plus 2, that expression, to be less than or equal to 3 away from 0 on the number line. So I need that expression to be in between negative 3 and positive 3 on the number line. So to write that it's in between negative 3 and positive 3 on the number line, we would have this expression. Y is sandwiched in between negative 3 and positive 3. And then you can just solve from there. All right. So number 1, we first need to get the absolute value by itself. So on number 1, I need to get rid of the plus 5. So I'm going to subtract 5 from both parts. And I have the absolute value of x is less than or equal to 4. So I want that expression to be less than or equal to 4 away from 0 on the number line. So I need to be in between negative 4 and positive 4 for that expression. So I need x minus 4 to be sandwiched in between negative 4 and positive 4 on the number line. I'm going to add 4 to both sides. And I get 0 is less than or equal to x, which is less than or equal to 8. So I need the values for the x to be in between 0 and 8. So my number line would look like that. On the next one, I need to get the absolute value by itself first. So I'm going to add 4, and then I have 2 times the absolute value of 3x minus 4 is less than 10. And then divide by 2 and divide by 2. And then I have the absolute value of 3x minus 4 is less than 5. So now I want the quantity 3x minus 4, I want that to be less than 5 away from 0 on a number line. So to be less than 5 away from 0, I need to be in between negative 5 and positive 5. So I need that expression, 3x minus 4, to be in between negative 5 and positive 5 on a number line. So sandwich it in between negative 5 and 5. It needs to be bigger than negative 5, but less than 5. So add the 4, add the 4, add the 4. And I get negative 1 is less than 3x is less than 9. Then divide everybody by the 3. And I get negative 1/3 is less than x is less than 3. So I need my x values to be in between negative 1/3 and positive 3 on the number line. And those would be open circles, and then in between negative 1/3 and positive 3. What if my absolute value goes the other way? So I want the absolute value of my expression or my variable to be greater than a value. So for instance, if I want the absolute value of x to be greater than 3, then that means instead of looking at it and being like, I want the numbers in between negative 3 and 3, I want the absolute value. I want its distance away from 0 to be bigger than 3. Well, to be bigger than 3 away from 0, I would need to be at like 4 or 5 or 6 and so on. So my graph would look like that on the positive side. And if I want to be more than 3 away from 0 on the negative side, I would need to be at like negative 3 or negative 4 or negative 5 or negative 6. So my graph looks like that. So notice this would be x is less than negative 3 or x is greater than positive 3. So for these, we're going to have to write them as separate expressions because notice for the distance to be greater than 3 away from on the number line, it's not going to go in between negative 3 and 3. It's going to go on the right side of 3 and on the left side of negative 3, which would be an or statement. So if I want the absolute value of x to be greater than 4 on a number line, then that means it has to be more than 4 away from 0. So to be more than 4 away from 0, I need to be at like 5 or 6 or 7, or I need to be at negative 5 or negative 6 or negative 7. So I need x to be less than negative 4, or I need x to be greater than positive 4. And so those would be my two different expressions for that one. What if I need an entire expression to be greater than or equal to a number, its absolute value? So that means that my two expressions, I need to be greater than 3 away from 0, so I need to be bigger than bigger than positive 3 or less than negative 3. So I need y plus 2 to be less than or equal to negative 3, or I need y plus 2 to be greater than or equal to positive 3. So I'm going to write the expressions separate, and then I'm going to subtract 2, and I need y to be less than or equal to negative 5. And I'm going to subtract 2 and subtract 2, and I need y to be greater than or equal to 1. And this is an or. So y has to be less than negative 5, less than or equal to negative 5, or greater than or equal to positive 1. So that would be my solution and my solution graph. All right, so same thing here. The first step is we would need to get the absolute value by itself. So subtract 3, and I have the absolute value of x plus 4 is greater than 9. So I need my distance away from 0 to be more than 9. So I need to be 9 or bigger, or negative 9 and smaller. So we're going to write two expressions. X plus 4 is less than negative 9, or x plus 4 is greater than positive 9. And then solve both of these. So subtract 4, x is less than negative 3, or subtract 4 and subtract 4, x is greater than 5. So I either need to be smaller than negative 13, sorry, I think I said 3 earlier, or bigger than 5. So my two solutions are x's are smaller than negative 13, or x's are greater than, just greater than 5. On the next one, get the absolute value by itself first. And so I have 2 times the absolute value of 3x minus 1 is going to be greater than or equal to 4. Divide both sides by 2, and I have the absolute value of 3x minus 1 is greater than or equal to 2. So I need 3x minus 1's distance from 0 on the number line to be more than 2. So it either needs to be less than or equal to negative 2 to make that happen, or greater than or equal to positive 2 to make that happen. So again, I need to be either more than 2 on the number line or less than negative 2 on the number line to make that happen. So set 3x minus 1 less than or equal to negative 2, or 3x minus 1 greater than or equal to positive 2. Then solve. Add 1, 3x is less than or equal to negative 1. Divide by 3, x is less than or equal to negative 1/3. Or add 1, 3x is greater than or equal to 3. Divide by 3, x is greater than or equal to 1. So those are my two inequality solutions. So x is either going to be less than or equal to negative 1/3, or greater than or equal to 1. All right, what about these? What if I want the absolute value of something to be less than 0? Well, what's a number that would be less than 0? It could be like -1 or -2 or -3. When is the absolute value of something negative? Is it ever negative? It's never negative. So there's no solution to number 1 because absolute values are never negative. They're never less than 0. What if I want the absolute value of 4x minus 8 divided by 3 to be greater than 4? So I need that expression to be more than 4 away from 0 to make this true. So to make that true, I need 4x minus 8 over 3 to be less than negative 4, or I need 4x minus 8 over 3 to be greater than positive 4. We're going to get rid of the denominator first, so we're going to multiply both sides by 3 and by 3. I'm multiplying by a positive number, positive 3, so I don't have to flip my sign. So I have 4x minus 8 is less than negative 12, or multiply by 3, and we have 4x minus 8 is greater than or equal to positive 12. And now we're going to solve both of these. So add 8, and 4x is less than negative 4. Divide by 4, x is less than negative 1. Or add 8, 4x is greater than 20. Divide by 4, x is greater than 5. So on a number line, the x values are going to be less than negative 1 or bigger than 5. All right, your homework is from 4.3 and 4.4 from your book. If you have any questions, let me know.